Welcome to my channel.
Today we want to treat the concept of differentiation. Differentiation, the concept itself starts from the gradients of a curve. When we say gradient of a curve, we all know that the gradient of a curve is not constant. It varies from one point to another point on the curve, unlike a straight line. When we draw a straight line, the gradient of a straight line is constant. But for the case of a curve, it varies. The gradient of this curve at this point is not the same as the gradient of the curve at this point. It's not the same as the gradient of this curve at this point. So when we want to determine the gradient of a curve, we are going to draw a tangent to that curve at that particular point on the curve where we want to determine the gradient. So this diagram, the gradient of this tangent is the gradient of this curve at this particular point P. But before we consider the gradient of the tangent, we start with the gradient of chord PQ. Because we can relate the gradient of chord PQ with these two changes in x and y. Because at point P, the coordinates at point P, we are having x, y. When x changes to a new value x plus delta x here, that means this interval is delta x. So when we add delta x to x, we add a new value of x. So x plus this small change in x produces the new value of x that we have here. The same thing is applicable from this point y. If y changes its value and we get a new value, that change can be represented as delta y. So when we add delta y to y, we get a new value of y. So the coordinates of point P is x, y, while the coordinates of point Q is x plus delta x, y plus delta y. So from definition of gradients, gradient is equal to change in y over change in x. Or we can simply use these two representations. Gradient of the chord PQ, a straight line, the gradient of this chord is equal to delta y, gradient of PQ, is equal to delta y over delta x. So when the delta y over delta x is written as a ratio, that means it represents the gradient of the chord PQ. But we want to determine the gradient of the curve. The curve is a function of y equals to x squared. So if we draw a tangent at this point, we will notice that if we move this point Q closer and closer and closer to P, the gradient will start to what? Decrease in value. If we move Q to this point Q1 and we move Q to this point Q2, it will get to a point whereby point Q will what? Will coincide with P. That is, if this point Q moves closer and closer and closer until it coincides with P, therefore our chord PQ becomes a tangent. Again, when we move the point Q, this other end of this chord, we move the point on the curve closer and closer and closer to point P. The chord PQ changes to what? A tangent when Q coincides. When we have Q at this point too, it coincides with P. We now have tangent to the curve at P. So that means this formula itself, which is the gradient of the chord PQ, is approaching a limiting value. Gradient PQ1 is not the same as gradient PQ2. And gradient PQ is not the same as gradient PQ2. So that means delta y over delta x, this gradient is approaching what? Is approaching a limiting value. The value of delta y over delta s cannot go beyond this point. So if we move the point closer, that means this delta y over delta s itself will approach a certain limit. So that limit is called dy ds. And dy ds can be written as limiting value of delta y over delta x as delta x approaches 0. As we move q closer and closer, you notice that the value of delta s also decreases. Delta s also decreases as q moves closer and closer. So that means delta s is decreasing and decreasing and decreasing and decreasing. We say it approaches. Delta s is tending to 0. So this limiting value of delta y over delta x is what we call dy dx, which represents the gradient of this curve at point P. The gradient of the curve at point P. So we can just say that dy dx at P. Dy dx at P is equal to the limiting value of delta y over delta s as delta s tends to 0. So we'll be using this formula for dy dx. So simply, when I say dy dx, I always say differentiation. Differentiation is the gradient of a function at a particular point. Now, in simplicity, because it has many applications, so it depends on a particular situation. But from the first principle itself, dy dx or differentiation is what? The limiting value of delta y over delta x as delta s tends to 0, which represents the gradient of a function at a given point. So the gradient of this curve at this point P is equal to this formula. So this formula can